Lecture 51 is the beginning of the final part of our crystallographic development. This is the remaining strategy now for developing the 14 3D space lattices and the 230 3D crystallographic space groups. So our strategy is continuing from before. Recall that we had developed 32 3D crystallographic point groups. So those are sitting out there waiting for us now to throw them into lattices. And we have already developed 17 2D plane groups or 2D space groups. And what we're going to do is first, the next few lectures, take those and evolve them because of adding a third translation into the 14 3D space lattices. And these are also known as the Bravais lattices. So again, it's actually just taking these 17 2D plane groups. How do we add the third translation vector? And the criterion leads us to 14 3D space lattices. These are categorized, by the way, into 6 3D crystal systems. And we'll show you that later. But basically, all it means is that you have some sort of larger framework and then some specialization within it that leads to these 14 subspecies. But these are the 14 3D space lattices or Bravais lattices. What we're going to do then is take these two and finally merge them. Remember, in 2D, it's exactly what we did. In 2D, we had taken the point groups and then we inserted them into the compatible lattices. And we're going to do the same thing here. And we're going to only have to add one little piece of new data, a new thing in here, which is you can only have in 3D, which is a screw axis. That's the only new component that we'll have to add. So everything else has been added. There will be, a new combination theorem where what we'll find out is in 3D, we'll have a general translation and a rotation, right? That ends up creating a new rotation that is a screw axis. And so we'll just add that, and then that will lead to the 230 3D crystallographic space groups. So a few words here before we finish this short lecture, which is that this we just finished up. Now, at first, you think that this first step in itself is going to be complicated because we had these 17 2D point groups, which it took us a while to derive. And so the logical conclusion is, oh boy, when I add a T3, it's just going to get more complicated. And the reason that it actually does not is symmetry. And so what you start to realize in this whole development is a lot of the work, and we spent a lot of time going through here in 2D, actually puts a lot of restrictions on the lattice especially. And so actually when you add T3, because it has to be compatible with the symmetries in here, we'll actually jump in and get these space lattices fairly quickly because the ways in which we can add a third translation vector to be consistent with all the symmetry elements actually is fairly limited. So all this symmetry you put in there, in other words, has to be preserved, and it makes our job going to here pretty easy. Of course, a much more complicated job is when you merge these two. The good news is that fundamentally, new things that appear are really only related to this new element, the screw axis. And besides that, all that happens is we have to look at the consequences of adding these point groups in there and making sure that all of the other symmetries are multiplied throughout the structure. And that's why this number balloons quite a bit, because there are many, many different ways with these 32 point groups and all these lattices. There's a lot of different combinations. But it's basically a lot of busy work except for this part. So our strategy is going to be, because we want to go on to properties, of course, is that hopefully you've seen now, and remember from here, this came from what we had done before. We were taking our 11 axial combinations, right? Which in turn came from our previous work as well. So just to remind you what happened there, and those axial combinations where we ended up adding, inversion went to 3D and everything. So all that work, really the red box and the blue box pretty much are the fundamental part of this. And adding T3, the symmetries already did here, like I said, actually make this work pretty easily. And then adding these two together is sort of combinatorial, more or less. And so the only other fundamental part that we'll discuss is a screw axis. We won't go through the 233 3D crystal space groups. We'll talk a little bit about notation and so show you some and expect you to be able to look at these and understand what they are. But to move on to properties, we will stop there and just give you a list of these things and expect you to understand how to look at them.